Hello, Steve Goodwin here with my anchor test video number 126. Today I'm going to introduce to you a new seabed in which I have begun doing anchor tests. It is a broad and wide sandy beach out at Ocean Shores, Washington. Now the whole west coast of North America is nothing but a large lee shore with many thousands of miles of fetch here in the North Pacific Ocean, and this results in a near constant surf and wave surge that pounds this beach relentlessly. I've been going there for 50 years now, and it's just every time there's been a surf running. And it's in that surf that I have conducted the tests, sort of a winch pull resistance test for all the 20-pound range anchors so far. I did not do any testing in the moist sand or the dry sand. To me, that just gets a little bit too abstract. I know some of you are going to frown on my decision to do beach tests at all because, granted, you don't anchor your boats on beaches, so I get that, but it's my goal here to try to test anchors in as many different seabed varieties as possible, and I am constrained by time and money. I just can't travel the world on a whim with all this gear, so I'm going to try and do as many different seabeds as I can locally. Now this beach is firm enough to drive on, and it is allowed to drive on. So I was able to drive the truck out there with a pile of anchors. I used the winch that I have been using in the boat. I have mounted on the back of the truck. So we're going to get some winch pull or winch resistance numbers. I have done all the testing in the water, however. So the waves crash onto the beach, and then uphill of that, there'll be a surge of water that flows up and then flows back. And it was a bit of a challenge getting the anchor positioned correctly, but that's what I've done. I've tested all the anchors only when there is water present. It was my hope in this, what I hoped it was going to be is a hard sand seabed, and maybe I would defeat some of the anchors that have less setting ability. But that was a bust. Even the CQR, which I think we can all agree, at least it has the reputation of having a very low ability to penetrate hard seabeds, it did no problem. It set every time as long as there was water present. In the moist sand where the people are driving, the CQR actually did not set. It would drag continuously, but we're not even going to talk about it. I'm not going to put it on the chart. Again, that's just too abstract. So I think it's a pretty good test. A challenge that I had to face was I did not want to do a horizontal pull or an infinite scope pull. I like to do anchor testing at, say, middle scope numbers. And what we ended up with was a 6-to-1 scope. And you're going to be wondering, well, how the heck did you pull on an anchor at 6-to-1 scope without having the truck out in the water? And the answer is I constructed a large wheel that elevates the rode. This apparatus does go out into the surf, and it's waterproof and it doesn't float away, so it worked out real well. And before we get to the anchor test, I'm going to show you a minute or so of the construction of that big wheel. So here it is. Okay, let's get started with some winch resistance pulls. I'm going to give you the anchors in order of their winch resistance divided by the anchor weight. So we'll have normalized comparisons per anchor weight. And again, starting with the worst one, it is the 10 kilogram Lumar Claw.
We got water, 10 kilogram Lumar Claw, 40. No set.
I'll occasionally be calling out numbers. Those are kilograms that I'm reading directly off from that load cell. But the numbers that I'm going to show here on the screen, those are going to just be generic units of winch resistance per anchor weight. And you can do the math yourself. You know how much it weighs. You can do the multiplication and convert it to either kilograms or pounds as you wish.
Okay, the 10 kilogram claw has not set yet, and here comes water. And water. And I've seen enough. No set, 10 kilogram claw.
Here's a 26-pound genuine CQR. It had an initial peak of 530 pounds of resistance. It then rolled out and was down to 65 pounds. Then it reset and had a second peak of 700 pounds. And then it was hovering around 500 to 600 pounds toward the end of a 30 or so foot pull. Note that the shank was not buried and it was at a list of approximately 45 degrees.
Okay, the anchor was not upright. It was about at a 45-degree angle.
Next is a 24-pound Delta anchor. It had an initial average of about 580 pounds. It then peaked at 680 and then hovered back down at 600.
Okay, the shank was just beneath the surface of this. I couldn't see it until I touched it. So it wasn't super well buried. Okay, it's a 21-pound steel spade, S60. In water. 50, 80, 90, 120, 140, 150, 160.
So the Spade S60 had a steady climb up to an 800-pound peak, then it hovered at about 700 pounds.
330, 307, 300, 320. Okay, 21-pound spade. Very well buried.
Here's a 17-pound Mantis M1.
190, 220, 250, 250, 270, 260.
This anchor had a brief peak of 680 pounds of resistance and then hovered at around 600.
Okay, there's the 17-pound Mantis. After the final pulls.
I conducted 2 complete sets of the Sarca XL number 1, and the results were virtually identical both tries. It averaged around 600 pounds, and it had peaks of 750 pounds.
Okay, there is a 22-pound Rockna under here somewhere.
Now, unlike some of my other seabeds, this 22-pound roll bar Rockna did not have a problem of mud fouling, and it performed quite well. It had an average of about 840 pounds with a peak of 920, and then back down to a average of 820. Nicely buried. Worked really well here. Next best performer was the 21-pound Vulcan 9. It had an average of 900 pounds and a peak of 1,010. It's a pretty close spread between the average and the peak, so indicates this is a real consistent seabed and not a lot of variation. Also indicates that the anchor stays upright and doesn't oscillate in its attitude much. I'm guessing it just stayed right at that attitude and was being dragged along in a real stable way.
Okay, quick set 22 in here somewhere.
Next is the 22-pound Kingston Quickset. It had a sort of a hovering average of about 970 pounds and a peak of 1,050 pounds. I notice a bit of a list there on its retrieval. That seems to be common with the convex style anchors, to be a little bit less stable in roll as they are pulled through substrates. Next is the 21-pound Sarca XL number 2. It had an initial average of 1,100 pounds, then a very high peak of 1,430, then it was back down to 880-pound average.
430, 440, 450, 460, 480, 490. Still got water. 400, 410. Here's the XL number 2. There was a list. Viking 7.
I'm going to toss a smaller anchor into this mix of 20-pound range anchors. This is a 12-pound Viking 7. It had an average of about 790 pounds, peak of 880, and did very well. If you calculate its holding power per weight, it is right up at the very top of these non-pivoting fluke 20-pound range anchors. So really good performance with this small Viking.
Lots of water. 390, 390, 380, 370, 360, 320, 360, 370, 390, 400, 380, 350, 340. Okay, there's a Viking 7 under the water here. You see the roll bar just there. The roll bar did not bury, but the rest of the anchor did.
Next is the 21-pound Viking 10. It had a peak of 1,560 pounds and a hovering average of 1,430 pounds. And when you do the math, you'll see that the resistance per unit anchor weight is virtually identical to the smaller Viking 7.
Okay, here's the Viking 10 after its very strong pull. Okay, there's a 17-pound M2 Mantis under here.
The Mantis M2 is the last of the 20-pound range anchors that we will see today. That's going to share the top spot here with the Viking 10. It had a peak holding of 1,320 pounds and a hovering average of 1,100 pounds. So it's, again, just a phenomenal performance for the Mantis M2. Here's another anchor that is not part of the group of the 20-pounders. It is a 3¼ Mantis Dinghy anchor. This anchor has performed extremely well in some of my other seabeds, and it was no disappointment here as well. It had a peak of 530 pounds and several other peaks and sort of an average of 500 pounds. And if you do that math, this is more than double the holding power per anchor weight than any of the anchors we have seen thus far today.
220, 230, 220. Okay, Okay, here's the Mantis Dinghy anchor. It is not at its peak here. It peaked up much higher, and then the holding started to go down, so it may have been deeper than this. But yeah, very, very impressive. Up around 500 pounds of holding, 3-pound anchor.
Okay, the last anchor that I will show you has by far the greatest holding or performance of any anchor that we've seen today. It is a 15-pound Fortress FX23. It had a hovering average of about 3,600 pounds with a peak of 3,850 pounds.
1150, 1160. Still got water. 1200, 1270, 1230, 14, 15, 15, 16, 17. We got water. 1750, 1710, 1720. Lots of water. 1690, 1670, 1660, 1650, 1640. Okay, it's the FX23 after a very, very high power. No way! I gotta go get a shovel.
Now, it would have been a whole lot less effort had I just shortened up this chain to, say, 2-to-1 or even 1-to-1 scope, and then used the winch. It would have pulled this anchor right out. But I really wanted to get an idea of just how deep it was and how much effort it was going to take to manually extract this anchor, and indeed, it was considerably well buried, and just took a lot of effort to get that out. I was concerned that maybe the waves were just going to keep refilling the hole, and that you wouldn't be able to get it out by hand.
Holy!
Here is a look at the ranking chart for the 20-pound range anchors. We'll see in the center we have the in-water tested performance columns, and in the far right of that group we see the new column, Surf Sand Holding. Got the numbers all plugged in there by rank, and we'll note that the overall averages did not change. The ranking of the anchors in total did not change as a result of adding this new Surf Sand column. Here's a look at the 20-pound anchor performance graph with our new Surf Sand seabed added in orange. Remember that all these numbers are the result of dividing the performance by the anchor weight, so we've got a real apples-to-apples comparison even amongst anchors that do not weigh exactly the same. I'll mention that I now have the anchors arranged from left to right in descending order of their average performance of all three of these seabeds. Okay, I've got all the anchors spread out on the bench in order of their performance from least performing to best performing. And whenever I do this, I kind of take a step back and look and see if there's a pattern or some generalizations that can be made about anchor design. And right off the bat, I just don't see much in terms of a trend. Let's take a look at roll bar anchors. We've got them up near the very best in the middle, and well, they don't occupy any of the worst slots, but they're spread out pretty evenly. How about convex versus concave? I'm seeing concave anchors up here at the upper end, and also down toward the lower end and in the middle as well. Same with convex. We've got them down at the low end, in the middle, and up near the top. Another element that anchor designers sometimes employ is the turned up trailing edge of the fluke. And if we scan across here, again, there's no real clear pattern. I would say that a CQR anchor does not have a turned up trailing edge, but a delta anchor does. We see a crease with an ear sort of turned up. A spade anchor has a turned up trailing edge. A Mantis M1 absolutely does not have a turned up trailing edge. It's dead straight. XLs have a turned up edge somewhat, as does a Rockna, as does a Vulcan. A quickset anchor is virtually flat aiming aft there. Here's another XL, we're turned up. A Viking is absolutely not turned up, and the Mantis M2 has only this small central tab that is turned up. So once again, absolutely no pattern whatsoever with that particular design element. So what is it that makes these two anchors at the top, what made them the best? And they're not just best by a little bit. They're 71 units of anchor resistance per unit of weight. The next best was down in the 50s, so significantly better than all the rest. And the one thing that I see here is extremely tall shanks. Maybe the Viking, this portion isn't quite as radically tall as the Mantis, but overall this is a very tall shank. Yeah, the XL is tall as well, but where do you measure it from? Do you measure it from here or down here? That's not as obvious to me. Otherwise, the Vulcan, it also has a fairly tall shank, and why isn't it way up near the top? So this tall shank theory is not ironclad. Like I say, it is just a theory. Now, in addition to just putting the fluke lower and deeper into the seabed, a tall shank can also have the effect of increasing what is sometimes referred to as the shank to fluke angle. And what it really is it's an imaginary line between the chain attach point and some sort of center or middle of the fluke's sort of, say, center of pressure and the plane of the fluke. And the greater that angle is, there is the potential for greater holding power. You're going to end up with an anchor that will dive even more deeply. The trade-off of having a severely large shank angle will be it'll be difficult for it to set in harder substrate. So that's kind of a balance for anchor designers to have to deal with. And indeed, these two anchors at the top end, I believe they do have a taller or steeper shank angle. It gets to be very difficult to say where the shank angle is on some designs. Like on this XL, how can I really say where the center of pressure is? I don't even know how high the center is. And also, what's the plane of this anchor? Is it the top here? Is it the bottom of the fluke? Is it somewhere in the middle? So coming up with the exact angular numbers gets to be very difficult, but I will say that there's not a clear pattern here. The Vulcan 9, boy, just visually, it may have one of the steeper angles, yet it does not end up at the top of the pack. It's nicely in the middle, however. Mantis M1s, you can just see visually, and they are known to have a fairly low shank angle, and indeed it's toward the lower end of the performance, but below it, though, we have the Spade, which has a bit taller shank and a somewhat more a greater shank angle. So once again, no real clear pattern. It's kind of cool that these two anchors that performed almost identically, one has a roll bar, one does not. One has the thinnest of flukes, the other one has a thickened, weighted fluke. Let's take a closer look at our worst performer for this test. This is the 10 kilogram Lumar Claw. I featured this anchor just a few weeks ago as a standalone test. I went through all my other seabeds, and it was generally poor everywhere. And what I theorized is that these real thickened edges, thickened leading edges of the fluke just doesn't let it penetrate well. It's known that anchors with a sharper leading edge will always perform better. And that's my theory with this anchor. What I'd really like to do is test this against a genuine 10 kilogram Bruce anchor, and we are in luck because a very generous individual saw my recent claw test and my thinly veiled plea for a genuine Bruce 10 kilogram, and here it is. This individual lives over near Seattle, and he drove it over himself and gave it to me. Very nice gentleman to do that. And as you can see, he filled a hole in my stack of genuine Bruce anchors. So that's certainly another thing that I'll be focusing on is my Bruce anchor scaling study. I do intend to take all these anchors back out to the ocean and give them that same test and see if we can draw some conclusions about scale. So I did test several other anchors out at the ocean, but this video is running a bit long, so I'm going to cut things off here and I'll show you those results at some other time. Okay, I want to give a huge thank you to everyone who is watching, supporting, and especially the folks donating to these anchor studies. Thank you very, very much. All right, as always, anchor safely, and we will see you next time. So long.